Hello everyone, welcome to our merge sort example. Here we're going to start with an array of 5 values, 57, 18, 25, 6, and 12. And we're going to take a look at the merge sort function. And the first thing to note is that, well, the function calls are highlighted with bold, they're bolded. And you'll see that inside of the merge sort function, it calls itself. And we also have a call to another function called merge. And for this video, we're not going to be covering merge. That'll be the next one, the next video on this. But right now, we're going to cover merge sort and merge sort only. So again, to reiterate, this is a recursive function because merge sort is calling itself. So let's start at the top of this function. So we're using a template with this function so that we can generalize it and use integers, doubles, floats, strings, whatever, right? And the first argument is that we have a vector of whatever it is, and it's called vect, and we're taking a reference to it. Then we have an integer called left index, which is our second argument, and an integer called right index, which is our last argument. Then we begin our function, right? So for this function call, left index is 0, right index is 4. And as we begin this function, we create an integer called mid index, and then we check if left index is less than right index. In this case, it's true. So then we calculate mid index and we call merge sort. So we're going to take left index and mid index and now consider it its own sub vector, right? Its own sub array. And we'll call merge sort again. And we'll actually continue to narrow this down leftward until we've broken up every single element of this vector into just one item. And when we go and build back up with merge sort, we'll piece everything back together. So here, highlighted with the underline, we're calling merge sort with this array. This array being what's highlighted in the red box. Right, so now we have a new highlighted red box, which is only 3 elements, and let's check with the if. Left index is less than right index, so we'll calculate mid index and we'll call merge sort again. Right, so left index, it stays the same, and mid index, as you can tell of the third argument of the underlined function called a merge sort, mid index is going to become right index. So we look at it now. This has been broken up into a smaller subarray. Now we're down to 2 elements, right? So left index and right index are still different, and left index is less than right index. So we'll call merge sort one last time because it's still highlighted, right? Now we're down to 1 element. Now we don't call the if statement because left index is not less than right index. They're equal. Since they're equal, we're going to go 1 level up, right? So the thing is, when we call this merge sort, we continue down, and now this is done. Now that this function call is done, we go 1 level up, and now we see that the second recursive function call for merge sort is now underlined. So now we're calling that, which now, instead of dealing with all the left-hand side data of this vector, we're going to be dealing with the right-hand side. Right, so we call this merge sort, and now we're only dealing with the 18. Well, if we check it with the if statement, left index is not less than right index. They are equal. So we go 1 level up. And then we see what's underlined is merge. So again, we'll cover merge in the next video, but what merge will do is that it will sort and merge these 2 elements together. And that's what we have. It'll take the 57 and 18 as separated variables and merge them and sort them at the same time, right? So now we'll go 1 level up. So the first 2 elements have been sorted on our recursive function called up, right? And now for this 3-element vector, we're finishing up the second merge sort recursive function call. Remember, this one was calling this, when it was at this level, it was calling merge sort here. And all those recursive function calls led to this. Now we're back up to this stage. And we'll call merge sort to separate the right side of all the array values. And we do that. And this is a little bit easier, and we're able to skip some more steps because it's only a 3-element array, and we've already finished comparing and sorting the first two. So we just have one element left, right? And here, since we only have one value, left index is not less than right index. So we're done with this function call. So we go one level up. And we're going to be merging. Well, what are we going to be merging? We're going to be merging the sorted 18 and 57 with the 25. And that is done. You'll see that the 3-element array that's below the red box is now sorted, right? And it's been adjusted for including that 25. If we look at the differences, right? Before the merge, it's unsorted. Now it is. So now we're way back to the top. And we got to start sorting the right side of this array. So we do that. So we have this, and we need to call merge sort. Since this is only 2 elements of a vector, it'll make things simpler, right? When we call the first merge sort recursive call, which is underlined, we'll handle the left side data. Then we'll move back up and handle the right side data. Right, we're down to 1 element. We can't trigger the if statement because left index and right index are the same. We break it up, and now we'll merge it. Coincidentally, this is already sorted, so nothing will happen. So now we're here, finally, at the end of the array, of the master array, calling everything. So we already have our 2 subarrays, which is the 18, 25, 57, and the 6 and 12. They're already sorted, right, as subarrays. Now what merge sort will do, it will merge these 2 subarrays to merge the entire array. And this is what it'll look like, right? And this ends the merge sort function call example. In the next video, we're going to take a look at merge and see how merge actually sorts and figures out how to merge these vectors together. Thank you.